Right, some people have asked how you change the speeds of things in Resident Evil 2. This unfortunately doesn't work with Resident Evil 1, and I'll go into that in a minute. But basically, you need to use the EDD, which is the sequence data for animations. Here I've extracted Leon's handgun's EDD using biofat. The whole entire structure is 4 bytes long, so every time it's 4 bytes, 4 bytes, 4 bytes, 4 bytes. At the beginning of the file is the actual sequence data, and basically it's the offset and how many frames are in a sequence. So at the start here, 1E is how many frames are in that sequence 0, and its offset is 44. Here you can see 44. This is the first frame, frame 0, from the EMR. I'll try and explain the EMRs in another video at a later date, but they're more complicated than the EDD is. As you can see, offset 40 here. That's the last animation in Leon's handgun. So there's 16 frames. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 0 to 16, 16. Well, technically 17, because it starts at 0. But the order for the animations for guns is quite simple. It's always walk, run, caution walk, well, walk, run, idle, caution walk, caution run, caution idle, danger walk, danger run, danger idle, aim, fire, and this is the hold. When you hold your gun and you stay stationary and you can turn on the spot, that's the frame used. It's only 1 frame long because it technically uses a frame from the aim animation. I'll show this later, but basically this frame here that this relates to actually has another frame from here. But then we got aim up, well, firing when up, firing holding up, firing down, holding down, and then you got reload. Some guns don't have a reload animation. Off the top of my head, the grenade launcher for one. The grenade launcher's reload is technically part of the firing animation. But for what you can see here, the first sequence, the walk, is here. And it's gone 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Usually it's 2 bytes long, and it's read from right to left, except for in this instance here where it's got a weird 6 here. That is 60, but technically that is probably a special function that's like a whole frame data or something. In Resident Evil 1, it's the same structure, 2 bytes and then 2 bytes, but the whole frame information is on these 2 bytes in Resident Evil 1. But in Resident Evil 1, you cannot control the speed of the characters via either the EDD or the AMR. You can only control this. I know it sounds counterintuitive, but in Resident Evil 1, the speeds of characters, how far they run in an animation, are not controlled by the EDD or EMR. In Resident Evil 2, they are. Well, they are in the EMR for Resident Evil 2. But here, 0 to 9 is a frame order at play. It doesn't always have to be 0 to 9, it could be any frames, but it's usually 2 digits long. Or should I say, it'll be like, what is it? 1.5 bytes, so that byte there, and then these 2 bytes here. We'll see it when we get up to the hundreds in hex. But as I say, that there is the firing animation. 17 frames in hex is 23, I believe. And the next one after that, 1 frame, which is hold. So 4D0, 52C. Go to 4D0, and we'll see that the starting of the firing animation is actually frame 10A in the EMR. And 52C here, that's the hold animation, 109. So this is using a frame earlier than here, which is the last frame of the aim animation. But the last frame here of the firing animation is 119. So you can see it goes A to 19. And say we want to make the character fire faster. Because basically firing is based off of how quickly the animation plays, rather than any other data, it's easily changed by just shortening the length of the basically of how many frames are played. You can see here we start doubling frames. But let's say we want to make it 10 frames long, or A frames long in hex. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Remember, one less because although we want 10 frames, we're starting at frame 0. So here we put the last frame, frame 19. The reason why I do this with animations is because some animations have movement in them. Like they might slightly offset the model from its starting position, or it might be moving forward a certain amount of space. And if it's not worked out correctly, the model can start juttering all over the place. However, if you take the last frame and move that to here, all this will be ignored when we change how many frames are in the sequence. But we do need to correct here because else we're jumping from frame 12 to frame 19, which can look ugly. So it's easy done just by doing a bit of math. So OC over E OF 10, 12, 14, 16, 18. So that's our new structure. I've got to mention, as you can see here, we've got 1 here, so that's 1 OA. This rarely gets, as I say earlier, there was a random 6 in the walk animation. I'm guessing that is the frame hold, and they've just done something slightly different with the structure here. But if you're not doing anything with frame holds, you're just doing the frames. That byte there, and that half byte there, and this byte here are all you really need to mess around with. So this sequence now goes from A to 19, but in a quicker order. We go back up here. There we go. There's the firing again. We've now changed that to 10 frames, which is A. 0 to 9 is 10 frames. That's that done. I'll save that. I'll use BioFat to re-import this, and then I'll show a video of the gun working in Resident Evil 2. As you can see, I've left the aim up and aim down the same speeds so we can do a comparison. Right, here we are in Resident Evil 2. As you can see, the gun is firing a lot quicker. I'll pop outside to the corridor just to show that it's actually firing and killing a lot quicker. As you can see, rapid fire. And just for comparison, here's the speeds of the aim down and aim up. Some final words. Although the EDD controls how many frames are played, for something like the aim, it is possible just to change the number of frames that are in the animation to make it fire quicker. However, a few caveats. If you're doing a run animation or walk animation, yes, you can cut frames out and it will make it run quicker because there will be a bigger jump between where the character starts and where the character ends, or the enemy ends. The EMR itself has coordinate data for how much the animation moves per frame. So by cutting out frames, you make it move quicker by having fewer frames. However, in the EMR, you can change the how much it moves per frame to make it quicker as well. But the problem is, something like the zombie, its AI doesn't think quick enough to do turning. So if you give it like a run animation of a human, it will just plow itself into a wall. But you can essentially take a few frames here and there from the zombie out of its walk animation, and that will make it quicker. And its AI will be sort of able to keep up with how quickly it's supposed to go. But be aware that certain things like attack animations for like enemies, like Mr. X's swing, they may be expecting the arm to be in a certain position at a certain point to do damage. This is more with Resident Evil 1 than Resident Evil 2, but it's always worth noting. Also, for example, with Mr. X, he hits with both his hands, with his left hand and his right hand. If you change the animation for his left hand to an animation that has a swing with the right hand, it's trying to calculate whether or not it's hit you using the left hand. But obviously the left hand wouldn't be anywhere near the character, so it won't do any damage. But I'll try and go into that more when I do EMRs at a later date. But unfortunately, EMRs are a lot more complicated. Not difficult, there's just more data to handle, more offsets, and everything isn't as nice and simple as the EDD, which is 4 bytes long. I forgot to mention, the reason why this doesn't work for Resident Evil 1 is because in Resident Evil 1, the speed of a character or enemy, how far they move, is controlled by the executable, not the EDD or EMR. Basically, the EMR doesn't have any data about how far the character should move per frame. Even though it's got the bytes for it, and if you put data in, it will just ignore it. It won't use it. So basically, speeding up the animation won't make the character quicker because it's not calculating distance from the EMR. It's calculating in the executable. So it's calculating it over how much time has passed. So every second it will move the character a certain amount forward, for example. Whereas with the EMR method in Resident Evil 2, each frame will have a position that it's supposed to go to. So the start of the animation might be, say, 0, but it finishes 1,000 in the coordinate, well, not 1,000, but like 500 in the coordinates later, and each frame will be somewhere between 0 and 500, so 0, 50, 70, 90, depending on how quickly it goes. So skipping frames just shortens how quickly it gets to that amount that it's supposed to get to.